the sections on the hyperbola. So the hyperbola is very similar to that last section that we just did for the circles and the ellipse. There are a couple things that are a little different, so let's go over those things. So the equation is still becoming the x squared over a squared, and then y squared over b squared is still equals to 1. The only difference now is going to be this minus right there. So that's what you're going to notice. If it's a minus, then it's going to be a hyperbola. If it's a plus, then it's either a circle or an ellipse. And the circle and ellipse can be determined by the denominator. If the denominators are exactly the same, it's a circle. If one of the denominators is larger, then it's going to be an ellipse instead. Okay, so we still need to find is the center on this one. The foci right here, notice that it is actually different as well, the formula for foci. For the circle and ellipse, it was c squared, and then it was one of the bigger ones minus the other one, but this one is a plus instead. So the way I usually remember is it's going to be the opposite sign of this right here. So if this is minus, then this is going to be a plus. And then the last one we just did was on a circle. So this is going to be a plus when we do circles and ellipse. So then this becomes a minus when you find the foci. Okay, so just remember it that way on the formula. Now we still find the vertices as well. But the difference on this one on the hyperbola is we're not going to actually draw the circle. We're finding exactly the same thing. Instead, we're going to go ahead and draw a square instead. So once you know what the center is, you're going to put a center. You're going to count out the y's just like how we did with the ellipse and the circles. We're going to count out the x's just like how we did with those. So normally on a circle ellipse, we would actually connect this, and then we would just make our circle or ellipse right here. But instead, in a hyperbola, we're going to do asymptotes. So we're going to create these little rectangle or square boxes, okay? And then from there, we're going to do slant asymptotes. So the slant asymptote, it has to be in the tip of that box right there, goes through the center. So in this case, the center is 0, 0, but if the center is anywhere else, then make sure it goes through the center and it enters and exits out of the corner. So goes from one corner to the center, comes out to the other corner, and then vice versa, goes one corner, center, and then out the other one. So these are all imaginary because this tells me is how wide the asymptotes of the slant is going to be how wide this hyperbola is. That's the difference on that one. So once we get there, then we're ready to draw the hyperbolas. So to draw the hyperbola, the trick of this is whatever's in the front part of this. So in this case, if it's x, then the hyperbola is going to open on the x-axis. So it's similar to that parabola. If you remember, for the parabola I said if it was a single one, then that's where it opens up on a single variable. But in this case, it's the first one. So if it's the first one, that's where it opens. So if the first one was a y, then you're going to open on the y-axis. So you would have hyperbolas on the y-axis on the top and then also on the bottom as well. Now, the vertex or the vertices are going to be the tip of that right there. So that's the vertex right there, and that's the other vertex. So these are the vertices for that one. And then the foci is always going to be on the side that the parabola opens. So it's in a way, it's two parabolas opposites of each other if you think of it. So this is the focus right there, and this is the vertex right there. So that's kind of what we're at right there, okay? So same thing with this one. If this is the vertex, then this is the focus. So the foci has to be inside of where the parabola opens at because it needs to be focused, similar to that the section that we did for the parabola, okay? So let's go ahead and try this then. So example 1, it has this 9x squared minus 16y squared equals 144. And similar to what we just did on the last section, you want it equal to 1. So you want to divide it out by 144 on all of these guys right here. 144 and then 144. So then 9 goes into 144 evenly. It should be then x squared over 16 minus, and then y squared over 9, because 16 goes into 144 9 times, and this is equal to 1. So now do the same thing as the last one. We want to go ahead and do the square root of it, so 4 squared like this, right? So that way it helps us when we do our counting out on the x-axis and the y-axis. So this is 3 squared and equals 1 right there, okay? So this is the equation, and then from here, we're going to graph it out. So our center is obviously 0, 0. So from here, our center is going to be 0, 0, 0, 0. And then on the x-axis, we're going to go out to 4 on the left and also to the right. So out to the 4, to the left, and to the right. And then for the y-axis, we're going to go 3. So we're going to go up 3, so 2, 3, and then down 3, 2, 3. And then again, we're going to go ahead and do rectangles instead of circles this time, or the ellipse. So rectangle. So use a straight edge for this, so you get a nice rectangle right there. And then it'll help also when you do the slant asymptote, when you do the using a straight edge. Okay, so now we're going from one corner, going through the center, and then come out to the other corner right there. So again, these are all asymptotes. So use a straight edge for this. It makes it easier to do it that way. And then it goes through here, goes through here, and then out to the other right here. Okay. So again, then from once we do all of this part right here, again, this is asymptote right here, you go back to the equation and you ask yourself which way is the hyperbola opening. So since the x is the first one right there, it's going to open on the x-axis. So on the x-axis right here, this is the vertex right there. So using this asymptote right here, go really, really close to this right here. This is how wide it should be. That's why the purpose of that asymptote right there. So it's be like this wide. And then same thing on this side right here. So you're going to go as wide as to the asymptote right there. And then go to the asymptote right there. So we want to then count out is, so I can actually put down is the, all of this right here. So center 0, 0. The vertices were negative 4, 0, right? That's one. Negative 4, 0. And the other one is 4, 0, right? Because that's this one right here. So we just need to now find is the foci. So remember, the foci is going to be plus because this is a minus out here. So it's going to be basically 16 plus 9, right? 16 plus 9 is 25. And the square root of 25 is equal to 5. So 5 from the center again. So go 4, 5. So that's your focus right there. And then 4, 5 right there. So those are your foci because there's two of those. So the order pairs are going to be what? 5, 0 and negative 5, 0. So negative 5, 0 and then positive 5, 0. Okay, so that's going to be then the hyperbola. Okay, so then we have to do is the challenging ones, which is the completing the square. So let's do that part. So similar to the other one. So we want to isolate all the x's, isolate all the y's. So let's do that. So since this one has 4y squared already here, so I'm just going to go ahead and do 4y. And then plus 24y, this is one group. And then I'm going to go ahead and put plus right here. I'm going to take out this negative right here, but for right now, let's just go ahead and put plus. It's going to have to be a minus out here, obviously for hyperbola, but let's just go ahead and put a plus. And so I have is then plus 4x is equal to negative 28. Okay, so we have to deal with some factoring as well. So let's do the first part, which is factoring the 4 out because you can't have a 4. So we factor out a 4, we have as y squared plus, it's 6, right? 6y. And then on this one right here, we're going to factor out a negative. So negative x squared. And then if I take out a negative here, I also need to take out a negative here. So it becomes minus 4x equals negative 28. And then we're going to start doing the half of. So 4y squared plus 6y plus, and then half of 6 is 3. So 3 squared minus x squared minus 4x. Half of 4 is 2. So equals negative 28. And then now we're going to have to do the 4. So it's 4 times this. Remember, we distribute this right here because that's a man-made. So it's going to be 4 times 3 squared. And then on this one right here, same thing with this one, since this is negative on the outside. So it's negative 2 squared. So 2 squared right here. Okay. So we have to clean that up. So we have is 4. We copy the variable. We copy the sign. Copy the number. Squared. And then minus. Do the same thing. Copy. Oops. That should be an x. X. And then minus 2 squared equals. And then if we clean that up, what does that become? Let's see. 9 times 4 is 36. 36 minus 4. Right, plus 28, I believe it comes out to 4. And so then from there, we're going to divide by 4 on everything. So in this part right here, we should have is y plus 3 squared over 1, right? Because if I divide by 4 on both sides right here, if I go divide by 4, this cancels out right there or reduces. And then this becomes x minus 2 squared all over 4. In this case, it just stays 4 equals 1. So this becomes your final answer right here. And then we start working with this one. So let's see. Now the set, so sometimes what happens is, let's say you did the x's first instead. So you did x squared right here. You brought it up in the front. You did negative x squared, and then you put plus 24, etc. So if you got a negative out here and you got a positive over here, what you're going to have to do is you're going to take the whole thing on this side right here and flip it to the back side. Because then this hyperbola, the minus always goes on the back side right here. So if you accidentally got a negative out here, which is fine, just then take the whole thing and flip it, and then, or switch it, right? Because then this positive should be on the front and then the negative should be in the back instead. Okay? So that may happen. So that's why I'm bringing this up, because sometimes it does happen. Okay, so now from here, let's do the center. So the center is the x number right here, and then the y right here. So it's the opposite signs, right? So we know the center is going to be 2, negative 3. So 2, negative 3 is the center. So 2, negative 3 is the center right there. And we're going to count it out. So on the y-axis, it looks like it's going up 1, down 1. Oops, I forgot to do 2 squared. So this is obviously 1 squared, right? Because 1 times 1 is 1. So we're going to count out y's of 1. So we're going to go up 1 and then down 1. And then on the x-axis, we're going to go 2 because it's going to be 2 right there. So from the center, we're going to go 2. So that's 1, 2. And then from the center, 1, 2. So then from here, my rectangle box in this case, rectangle, it's going to be small, and then it's going to go from the corner to the center. Make sure it goes to the center. And again, this is why straight edge is really helpful. When you're using a straight edge, you'll be able to see that better. Okay, so once we get here, all of the drawing part is done for the asymptote. Now we have to go back and decide which way does the hyperbola open. So since this is the first one right here, and it opens on the y right there, so that means it's going to open on the y-axis. So here is the tip of that right there, the vertex. And so we're going to use this asymptote right there. That's going to give us how wide it is. And then same thing with this one right here. That's the tip right there. So it's going to go down here. And then it's going to go down here as well. Okay. So then from here we're going to find is the foci. So the foci, we're going to add the two numbers together. So that's 4 plus 1 is 5, right? Because it's 4 plus 1 is 5. Square root of 5 is about 2.24, I believe we found from the last one. So 2.24. So again, it has to be on the side of the parabola. So this is going to be 1, 2.24 is up here, and then this one's going to be 1, 2.24 is going to be here. Now, sometimes the foci is closer to the vertex and sometimes it's not. So how is that happening? So what happens is this right here, it's kind of like the guiding line. You would take like a string and then you would draw this right here. So the wider this is, most likely there's going to be going back a little bit more. And then the narrow that becomes, it's going to be closer to this because you won't need the spacing for that right there. Okay. So it's not wrong if it goes back further, and then sometimes it'll be real close to it. So it's going to fluctuate from that depending on how wide each of those parabolas or hyperbolas become. Okay. So the focus then, we're going to add 2.24 to each of those. So let's see, the vertex, let's do the vertex first then, or vertices. So the vertices were 2 and then negative 2, right? So 2, negative 2, and then the other one was 2, negative 4. So then from there, the foci is going to be 2.24 more from the center. So from the center was at 2, so let's just add from there. So, or I'm sorry, negative 3. So 2. So if I add 2.2 something, it should give us 1 point something, right? 1 point, let me see, 3, negative 3 plus 2.24. Right, so it's going to give us what, negative 3, 1 point something. I didn't calculate this one. Let's see, negative 3 plus 2.24 should give us negative 0.75 or 76. Okay, so negative 0.76, and then the other one should give us 2. And if I add negative 3 minus 2.24 should give me negative 5.24. Okay, and then you can probably see that when you count it out from there. Okay, so that's going to be then is the hyperbola part of it. So it's the opposite of the circle and the ellipse in the sense that the sign right here in the middle is going to be a minus instead of a plus. Okay, all right, try this out now.